In this question, we're given different conditions to solve for the missing letters. So let's start off with what they tell us to do. So x equals b sine nt plus cos c cos nt. And we're told to have a look at the velocity equation. So velocity becomes bn cos nt. We're just differentiating with respect to t. Minus cn sine nt. All right, so in the first question, we are given the period is 4 pi. Now we know the period is 2 pi on n, and we're given that the period is 4 pi. So you can see that n must be a half in order for that to happen. So, all right, so we know n equals a half. And we're also given some initial conditions. So we're told when t equals 0, x is 6 and v is 3 at that time. So let's use that in the equations, in both the x and the v equation. So if x is, we'll make x 6. So when t is 0, we know sine 0 is 0 and cos 0 is 1. So we're only going to get the c. So if I make the cos 0 is 1, I'll just get c. So 6 must be c from that one. In the velocity equation, if I make velocity 3, again, the sine part, this part's going to go to 0 because sine of n times 0 is sine of 0, which is 0. So I'm just looking at the cos part here. So cos 0 is 1, so bn is what I'm going to get. So I've got, I know 3 is b times n, and n we've got is a half. So clearly b must be 6. All right, so if we know that, if I put them back into the x and v equation, put everything in we know x must be 6 now, sine t on 2. What's c? C is also 6, so I'm going to get 6 cos t on 2. And v is equal to then 3, so bn, so 3 cos t on 2 minus 3 sine t on 2. So they're my equations. Now we can find the 2 times the particle is at the origin. So really we're using the x equation, and we're saying when x is 0. So when we make x equals 0, clearly the sine t on 2 has to equal negative cos t on 2 in order for that to work. So let's just make that. So sine t on 2 would have to be equal to cos, or minus, I should say, minus cos t on 2. And then x would be 0, which is what we're looking for. So therefore tan t on 2 would have to equal negative 1. So if you're thinking, oh, stations 2 central, when is tan negative? Stations 2 central. So here and here. So we know that actually tan, I'll put it there. So you know tan pi on 4 is 1, so we can look at this quadrant, which is pi minus pi on 4, and this quadrant, which is 2 pi minus pi on 4. So we're looking at these two angles here, 3 pi on 4 and 7 pi on 4. Alright, so 3 pi on 4 and 7 pi on 4 are the first 2 times that happens. Just move that up a little bit. Alright, so therefore the first 2 times that happens, if I now times by 2, I'm dividing by less there and less there. So at these 2 times, that's the first 2 times the displacement is 0. Alright, so that's for the part A, that's the conditions we were given. So let's have a look at part B. So in these ones, we're given just different conditions, that's all. So let's have a look at those different conditions. So I'll get rid of that carefully, more carefully than last time. Okay. So this time, what do we know about the, so we're given the period 6. So again, we're going to have 2 pi on n is 6. So n is going to be 2 pi on 6 or pi on 3. All right, so we've got n is pi on 3. We know at initially, so at time 0, we have x equaling -2 and velocity being 3. So let's use the displacement equation first. So remember, if it's time 0, the sign disappears. So we've just got x equals c, cos 0 is 1, so x equals c. So in this case, x, which is -2, equals c, so c is -2. All right. Let's get the velocity equation. So when v equals 3, we just have the bn because cos 0 is 1. So we have b times n, and n is pi on 3. So b would have to be 9 on pi if we solve for b. All right, so let's put those back in the, we only actually need the x equation, don't we? So x equals, so we've got b sine n is pi on 3, right? Pi on 3t minus c is -2, so -2 cos pi on 3t. All right, so that's our x equation, and remember we want our x to be 0. So if our x is 0, then 9 on pi sine pi on 3t will equal 2 cos pi on 3t. That's if I make x 0, that's what I'm looking for. So if I make it tan pi on 3t, I have 2 times that pi over, divided by that 9. So that's what I'm going to get. So remember, it's the first 2 times. So this time tan is positive. So we're looking at the first and the third quadrant. So that t is, first of all, we've got to inverse tan that 2 pi on 9, and then we're timesing by the, so that would be pi on 3t, so then I'm timesing by 3 on pi. All right, that would be the first time. The second time I would take, I'm just going to put a bit more room there. All right, so I've got the inverse tan of 2 pi on 9, which gives me my first angle. In the third quadrant, I want to add pi, right, to make it in the third quadrant. And again, that would be pi on 3t. So if I just want t, I've got to times by 3 divided by pi. So if you do that in your calculator, remember to be in radians. To 3 decimal places, the question says. So that would be 0.582 seconds and 3.582 seconds. They would be the first time it has 0 as its displacement.